Hello and welcome. My name is Bob Tickelman. I'm a Microsoft technical trainer, and I'm excited today to present to you this session on what you want to know when you want to know it. Today, we're going to be looking at designing Microsoft Azure infrastructure solutions as part of the Azure 305 Architect course. In this module, we're going to be taking a look at networking. Now, you're going to probably say, what's new with networking? In fact, there's not much. And the whole idea of networking is that your on-premises legacy understanding of networking should work virtually the same as it does inside of Azure, and that's exactly the case. Now, we're going to show you how that translates and some unique features in Azure that takes a superset, everything you know about networking, and blows it up into a superset or a bigger feature set that allows you to control things inside of Azure. Now, some of the things we'll take a look at is what is that networking architecture, and we'll take a look at what you know as a TCP IP address, public and private. We'll show you how that translates to public and private IP addresses inside of Azure. We'll take a look at, a thing called a VNet and a subnet. Now, those might be slightly different than what you've used them, but those are the terms inside of Azure. And we'll show you how you can provide connectivity inside of Azure, whether it be in the same VNet, between subnets. We're going to show you how to connect VNets in the same region and then go across multiple regions. Again, it's very similar to the kinds of things, and you'll see some auto magical pieces that happen. You're not going to have to create VPN gateways and gateway subnets to have that infrastructure communicate inside of Azure. It uses what's called the backbone of Azure. Now, we'll then take a wide area network look and taking your on-premises network and merging that together with your Azure infrastructure networking that you've built. And now we'll take a look at the methods that you can tie that, and that would go back into that traditional VPN. You've got gateways that you've got gateway networks that you're building. And we'll also show you some advanced capabilities using a thing called hybrid networking, or where you can work with a thing called Azure ExpressRoute, where you can get high-speed MPLS network connectivity into Azure. So we'll take a look at all these different features, and then we'll take a look at some of the traditional security pieces like firewalls, and we'll introduce a feature. We've got firewall pieces of devices, and whether they be an Azure firewall or even third-party marketplace, Cisco and F5. We got load balancers. We'll take a look at this thing called an application gateway. And a feature called Front Door, as well as Traffic Manager, to provide that global as well as regional-based routing capabilities for your applications. So we'll get into all those individual pieces of networking, taking everything you know about networking and layer on top of it some Azure-specific services. So let's get into that lesson. Once you start taking a look at networking, and it's where we often start the cloud journey, is understanding, because to work in the cloud, you need some kind of level of networking, because unless you're working in one of our data centers, you're going to use a network segment to be able to get into Azure. We want to make sure that we understand the totality of the scope of networking itself. And there's a base unit that we'll take a look at called a VNet. And I don't want to make this a whole networking segment as architects, but it's important that you understand the base building blocks and see how they then become the foundation for a thing called defense in depth, which says you do not just want to have a perimeter network. Gone are the days where people, term you might have heard, bastion walls. They would put up a perimeter around their network and thinking that my job is done. I can cross my arms and we're safe and secure. Well, the vast number of security breaches happen from within inside of those bastion networks. And so you've not just only got to make sure that you protect the perimeter of your buildings physically. You want to make sure that there's a gatekeeper at the entry to the building itself. And once you get into the building, you want to make sure that every single floor that you go to, you have access to. And when you get to that floor, you want to make sure that every single room has access to it. So you want to have this defense in depth. And we've got documents that talk about all of it, to build this perimeter environment and make sure that at all levels, and not only on the way in, you want to make sure it's difficult to get things out, because you might have blocked something coming into the network. But if you don't also check on the outbound traffic, maybe that's going to be a potential weakness that you're working with, because if I come from inside of a secure environment, get in and then extract it to another secure environment that's been compromised, you could have been potentially able to block that. So that's the level of complexity we take a look at here. They're coming up and making sure that you're gathering all the requirements. They mentioned things like naming conventions. You want to follow them. It sounds simple, but it can have a huge impact, because it's simple to identify someone who's gone rogue on you and built something if they're not following the naming convention, because it will stick out very much like a sore thumb when you're looking at naming conventions of objects and you're seeing all the networking firewalls being named the same way and you see something that's not there, or not following that naming convention. It will really be obvious for you as opposed to finding other methods to work with it. So not really a secure component, but it is part of that security that if you follow these standards, it makes things a little bit easier. Looking at the different regions that you have available to you, the use of subscriptions and locking them down, all of these pieces together are part of that requirement of which policies are going to be applied, what permissions. We're going to take a look later on at a thing called JIT, just in time, and JEA, or just enough administration. All of these things are not just going to give you access to permissions, but at what time do you need those permissions, and being able to elevate only at that time you're dealing with it. Today, I'm going to be talking about Azure architecture, and we're going to take a look at the Azure network connectivity services that are available for you. So let's get into this. At the foundation of all things in Azure is a thing called a VNet. And so this becomes the base unit that every resource has to be accessible through some type of networking. Even if it's from one service in Azure to another service in Azure, the VNet becomes the building block that you work with. Now, there's lots of things that you might want to consider from an architect's perspective, because you're going to need an IP address, and there's topics that you might want to consider not part of this one, where you look at public versus private IP addresses. Which private IP address range do I use? Do I use the 10. network, or do I use the 172.16 network, or do I use the 192? Can I reuse IP addresses? Because 10 is great, but 10.1 I might use, and does somebody else use 10.1, and are they going to overlap? So a lot of conditions that you might want to consider that we're not going to cover here, but this as a base unit, from an architect's perspective, you want to understand how it's going to work, because this is where you take a look at, from a defense in depth perspective, where you start your security journey, what can get into the network and what can get out of the network itself. So I'm just going to take a look at a couple of foundational pieces on a whiteboard session, and we're going to come back into the slides and talk about that topic itself. So let me just go to the whiteboard now and talk about this thing called a VNet. When you take a look at a VNet, that is the base unit inside of Azure, and you'll see this symbol itself. It is going to get an IP address. I'm going to use my 10.1 here, /16, which means that is the network address. Now, by default, it's going to allocate all of those IP addresses to this VNet itself. I then can create a thing called a subnet, where I can take that IP address and break it up into several subnets within my VNet. So that's hopefully the language that you'll hear people refer to it, and it has a slightly different symbol. And I'm going to call this the 10.1.1 network. This is going to be my 10.1.2 network. This is my 10.1.3 network. By default, nothing can get into this VNet, nothing can get out of this VNet, and that's where you're going to start part of that security journey. But by default, everything inside of that VNet can talk to each other. So while there's 3 different subnets, we have a thing called a system-defined route. And by default, all subnets can talk to all other subnets within the VNet. You're going to show, and I'll show you how to set up the permissions to block this down, because what we often talk about is a 3-tiered or N-tier network. If you go to the Microsoft architecture, we talk about designing for an N-tier architecture on how to lock down and have what are called UDRs, or user-defined routes, where I can now override the system-defined routes that are built into the subnet itself. And so we can start to lock this down to say that, I only want my front end talking to the middle tier. And I only want my middle tier talking to the back end, and I'm going to block that kind of traffic. We expand this out to include potential other subnets. Now, it's not obvious in the slide, so I want to draw it in here. Within Azure, from one VNet to another VNet, whether they're in the same region or across different regions, you can use the Microsoft backbone. So I can create what's called a peer. And so I can now have two VNets talk to each other. And by default, all the subnets in both of those VNets can talk to each other. Again, I can go over and define in a UDR how I want that routing to take place. But here's the security benefit of this. This is going to be secure communications from a Microsoft network through the Microsoft network of Azure back into another resource within Azure, whether it be in the same region, whether it be across regions or anywhere in the globe. So we have VNet peering is what it's called. And you have global VNet peering. If this is, maybe this is in EMEA, Europe, and both of these are in North America. It is going to then have secure communications across the Microsoft network. Now, this is not encrypted. It is secure. It uses what's called private networking. So we create a private network between one VNet and another, but it is not encrypted traffic. Now, this is going to be totally different. We'll take a look at other tools to bring this beyond that. So if you want to go from your on-premises world into Azure, you can do that, and we'll show you how to secure those components. So taking a look back at the course material, the virtual network is that fundamental building block that you're looking at, and that's what they're trying to show you here, is starting from the right-hand side of the slide, we've got those two VNets similar to what I was drawing, and within that VNet, you have subnets with resources deployed to them, and by default, you're going to see that spoke number one, by default, can't speak to spoke number two. There's no peering that's happening between those two. Bad drawing here. So they can't talk to each other. But spoke one, in what's referred to as a hub and spoke network, I have my hub network. Traffic can flow back and forth through that pattern. Traffic can flow back and forth through spoke two with hub. But by default, spoke one cannot speak to spoke two. And what that, from a design perspective, now allows you to focus some of your security requirements from a design perspective, architecture, at that hub network itself. So I can now start to deploy a whole set of resources like gateway services and firewall services at those hub networks. And then they would get the benefit of being protected at the spoke level because I'm going to be able to block traffic for malicious things into the network. And therefore, those two spokes at the other end of the hub network are going to get the benefit of the hub being protected. So that's kind of what they're showing you here. And from an architect's perspective, what you want to be able to set up. So they have these different patterns that you're working with. And so whether you put everything into a single virtual network, that first example on the far left-hand side, know that you can have them all in a single VNet within a single region, within a single VNet. But by default, all of the resources in one subnet are going to be able to talk to another subnet. So that's potentially a weakness that you're working with. Now, as I said, you can override that default pattern. Taking a look at pattern number two, the one in the middle, what I'm now going to be able to do is have my resources split across multiple VNets. They could be in the same region. They could be in different regions that you're working with if you wanted to. And you could then peer those resources together, those two VNets. And by default, remember that a VNet peer is going to then have the communication be secured from one VNet to another because it's going to be done across the Microsoft backbone itself. And by default, all of the resources in one VNet, because all the subnets talk to each other, but all the subnets in one VNet talk to all the subnets in the other VNet by default, but we can override that. Going to pattern number 3, the one on the far right-hand side, they're bringing in some central management in there because maybe they want to monitor traffic or restrict the traffic that is going to happen between that. So they've built a hub and spoke network in the far right-hand or the far left-hand side of that, region 1. And so maybe they're all talking to each other. And once they get to the hub, we could then actually have user-defined routes that allows them to speak through the traffic into another region potentially, or another application that they're working with that I can control that traffic. So 3 different patterns that you can work with as a starting point for your network. You want to be able to then potentially make your services in Azure globally available to something other than Azure itself. And so we need to expose that. Now, typically, you could put a public IP address at some entry point into your resources. Probably not a good idea because not only does that allow your application to go out to the internet, it allows the internet to come into your application. So what they're showing you is a pattern called a NAT, or network address translation, that allows you to then allow your subnet to speak out into the public environment, but not allow the public network back into your VNets themselves. There's 2 ways that you can work with that. So you can have a network address translation. Many of you might be having something similar to this at your home network. You might have multiple devices, your TVs, your phones, your PCs, that are coming through a single device, and it does a NAT through your internet connection provider. And you're going to get the public IP address, and you're going to now be able to speak on the internet, and they come back to you. Based around the volume of traffic you might be working with, we can also put up what's called an IP prefix, where you put up a range of public IP addresses that they can speak out through. So these are some of the ways you can work with it. Looking at the list on the left-hand side, other ways that you can design inbound and outbound connectivity. There's Azure firewalls and load balancers, VNet NAT gateways that you're working with. So there's a whole set of tools that are available for you to be able to control the traffic inbound and outbound through the VNets themselves. Here's the slide specifically that gets into the topic I was mentioning about the default routing. And I talked about within the VNet, multiple subnets in that VNet by default are going to be able to talk to each other. And that's that system routes that you see at the last of the bullet points. That's the default. But in an ordered list of processing, it's the last one that would be checked. So what you then have is the ability, then you can get into VNet peering that you're working with. But now I want to be able to potentially override that. I want to control how the traffic is going to go through. So now what I can do is shape that traffic with a thing called a UDR, or user-defined routes. As an architect, probably not your job to do, but it's important for you to make sure that you ask the question of the networking people, who it is their job to make that distinction. Does that network need to talk to all these other networks? Do we want to shape the traffic through a central network? Where are we going to put our security? Those are the pro tips that I would use as a designer or an architect of a solution. Not your job to implement it, but I think it is your job as an architect to ask the right questions about shaping of traffic in a design that you're possibly going to have to recommend. Today, we're taking a look at Azure architecture, and we're going to take a look at designing an on-premises connectivity to the virtual networks within inside of Azure. Let's get into this. We have a wide variety of ways to be able to connect from an on-premises network to Azure. We're going to skip the first of the steps. Is you can make your Azure resources publicly available, and you can come out through a public internet connection on your on-premises environment and then just connect to those services. Probably not the most secure way for either of those environments to be communicating. But we want to be able to set up a secure connection. And the first and easiest of these, and probably the most common, is to create a VPN, or virtual private network. And what you're going to be able to do is to create that VPN connection. These have been around for many years, that whether it's from office to office that you might have been communicating, some of you might even be using from office to home or home to office, creating a VPN tunnel, which creates a secure connection through a public internet communication method, and it creates what's called a tunnel and secure endpoints. Now, it's quite common. We've got a wide variety of tools that are going to be able to provide that. So at your on-premises location, you're going to need some kind of device that is going to provide that VPN connectivity for either outbound or inbound. Windows servers provide it. You get these products from network providers like Cisco have them. Inside of Azure, we have a wide variety of software-defined networking components. We have an Azure VPN connection that you're working with. There's also third-party providers from a wide variety of network providers available. So if you wanted to maintain that product brand specific management, you should be able to get that possibly from the marketplace in Azure. But what you're seeing in the center part of that slide, by creating a VPN device, and you're seeing down the slide, we have different SKUs or stock keeping units that, depending on the bandwidth you want to use, how many connections you're working with, you can define that device and then be able to make the connections between them. So we're not going to get into that. That's done in a networking course if you want to figure out how to do that. But we have a wide variety of SKUs, and you have the capability to be able to potentially, if it's under provisioned or if it gets used heavily beyond what your expectation was, in many cases, you might be able to scale up or scale down the throughput capacity of that unit itself. There are some limitations that we've got what are called Gen 1 and Gen 2 versions of these gateway devices. You can't scale up to a different generation. You'd have to redeploy that device itself. But from an architect's perspective, we've got a very convenient tool in a very well-known environment to be able to make that available for you. Moving up the ladder, Microsoft has this thing called an express route. This is a dedicated connection from a service provider that you would have to make a connection or a relationship with. So we have what are called POPs, or points of presence. So these internet providers, you would contact them, and you should give yourself about 30 days to set this up, because they may have to actually take a piece of wire from their POP or their network connectivity into your physical location. They will activate a thing called a circuit, and that will allow communications from your location to their MPLS network, typically is what it is. And then they guarantee bandwidth as little as 1 gigabit up to 100 gigabits per second that you can dedicate bandwidth to for this secure communication between your on-premises network and that service provider's network. And then they have a dedicated connection that routes through their MPLS network into Azure itself. All sorts of different features that they work with. They have SLAs that come along with this, and it's up to you to determine what speed and what commitment you're going to make. But as I said, you want to plan for this up front because it could potentially take a bit of time to set this up. We can also provide some backup to this. And so it's basically the same thing, an express route with a VPN failover. Not even for failover services. I've done this for a couple of customers where the vast majority of traffic is going to flow through the express route. Again, it's a secured connection, but it's not encrypted by default. You potentially could do that, but the default is not to do it. And for a specific application, they had it go through a VPN specifically because they wanted to segment that traffic significantly from the express route traffic that they're working with. But I'm not going to spend a lot of time. These are just showing you all the varieties of things that you could do if you wanted to at least consider them in your architectural designs. So we started off with just a public access to the resources. We looked at a secure connection through a VPN, fairly simple and inexpensive to set up. But it's maybe going to be limited if you have throughput requirements. And if you want to kind of flatten the network, you can then go to an express route. You can have an express route with some VPN backup where you're working with it. So you're seeing this level of complexity. Microsoft has introduced a number of global capacity features to expand that network capacity beyond having to have all of your offices potentially get an express route. Working with an Azure Virtual WAN or wide area network, these become resources deployed inside of Azure that become central connection points. And so in this example, they've defined 3 WANs for whatever reason. Maybe we've got one in Europe, maybe we've got one in North America, maybe we've got one in Asia. And so what we can have is those local resources connecting to those local WANs to be able to get access to the Azure backbone to be able to then communicate either to each other or into the Azure resources themselves. So you can see that I've got a variety across the bottom. Maybe I've got 2 large corporate offices that maybe have express route connections. Maybe I've got some small branch offices that are VPN connections to those virtual WAN connections. And then they aggregate that at the virtual WAN area that they're dealing with. Moving up, you can expand the virtual WAN to have a thing called global transit. And so now, as opposed to kind of these locations talking to the the virtual WAN, speaking into Azure, and they can come back, you've now opened up pipes for offices. So you're seeing, for example, in that bottom left hand, you've got a headquarter branch that maybe has an express route connection to Azure. So it's high speed bandwidth that's communicating. And it can go through the global WAN and come back to the branch office that might be connected to the virtual WAN through a VPN connection. So I don't need to go from my branch office to my main office. I can actually use the bridge that has been created through the virtual WAN to be able to create this global transit or global reach capabilities across my entire on-premises and cloud infrastructure. Today, we're going to take a look at Azure architecture, and specifically, I'm going to take a look at designing for application delivery services and the methods that we can use to secure and provide that connectivity. We want to be able to now grant access to an individual application. In other modules, we've talked about native network connectivity. Microsoft provides a wide variety of services from load balancers to things like app gateways, traffic manager, and front door services to provide a routing capability either within a region, across regions. We have all these different combinations, and depending on the cost, the availability, the type of filtering that you might want to have, there's a whole series of choices, and you're seeing that example of that on the flow chart, of ways that you can architect these possible solutions. So what is the traffic type that you're working with? What kind of security does it need to have? Is it global versus regional? And we've added services to this. So while, for example, we used to use a thing called Traffic Manager, it's one of the items that are listed there, it now has a counterpart called Front Door Service. And so they do very similar things, but one is a little newer. It has some newer features. And it takes on some of the new capabilities that were before. For example, I needed Traffic Manager and a feature called a CDN or Content Delivery Network to be able to do what Azure Front Door Service does. So it's not that one is deprecated. It's just that over time, we've been able to provide new services and capabilities that you may want to add, where in the past I've always built things with Traffic Manager and CDNs. You can still do that, absolutely, but you might want to take a look at a new feature, something like Azure Front Door, to be able to consider in your designs and architectures. So the first of these is a thing called a load balancer. This is not new. We have software-defined load balancers. There's an Azure load balancer. I've mentioned that you can also possibly get third-party load balancers. For example, F5 and Cisco, just to name a few. They have software-defined load balancers for their products that you probably have in your on-premises world. They're available to you in Azure in the marketplace, so you can define and deliver a Cisco load balancer if you wanted inside of an Azure solution, so that if your load balancing and network team wanted, they've got a set of rules and management tools to manage their on-premises environments, they can use those same tools to manage the Azure deployed ones. But we often talk about the Microsoft Azure services natively within that load balancing and other capabilities. The Azure Load Balancer is a layer 4 load balancer, provides all of that capabilities that you've taken a look at. It looks at packets. It provides heartbeat. It does heartbeat checks. We can do shaping of traffic. It's called a 5-tuple hashing that you can take a look at. And we have 2 different versions of that load balancer that they're trying to describe for you. It's called a public load balancer that has a public IP address that you can use to gain access to the services, and then a back-end pool. And then we have what's called an internal load balancer that does exactly the same thing. Why we have 2 products, I'm not quite sure, but one has a public IP address that you can assign to it, and one can only use internal addresses. And so just from, I guess, a security perspective, you don't want to have one that might get misconfigured. You can have, the same activity, taking that load into an entry point, creating a set of rules of how you want to balance that load out through the back end. Another type of load balancer is a feature called an application gateway. An app gateway is a regionally based unit, very much like a load balancer. Load balancers are deployed within a specific region. An app gateway is another regionally based feature, but it is not just a layer 4 load balancer, it's a layer 7 load balancer. So it can do a whole series of other features. It can do things like SSL offloading. It can actually do deep packet inspection and looking at it. So it's like a combination of a WAF, a web application firewall, and a load balancer to do this. And so there's a whole set of capabilities that we can use to route the traffic through the application gateway. The key here is it is a regionally based unit of that capability that you're working with. We then move beyond the region and we take a look at the global routing of traffic. Traffic Manager has been a long-standing tool since the inception of Azure to be able to provide a global routing capability. So if I've deployed an application, so maybe I've got a global organization, I've made my application available in the 3 theaters that I've talked about. I've got it in Asia, I've got it in North America, and I've got in Europe. I could actually have a single endpoint that all the traffic comes to. Now, Traffic Manager is a DNS lookup, so it's actually not going to shape the traffic specifically. It takes your request and across 6 different categories, it's going to say, I'm going to send you to a place based around one of these 6 choices that I've picked. Is it based around response time? Is it based around where your geographic request has come from? So we have all these different ways to shape it. And if you come from North America, it says, well, I'm going to send you to the North American IP address, and you might have an app gateway at the front end of that application that then fields that request. It's back end for the end user. They don't get to see that. Maybe just take a fraction of a millisecond longer to go to this lookup service and then get routed to the endpoint that you want to use to access the information. It provides some fault tolerance capabilities, but it's not session based. So that if a user, because once they get routed to traffic, they're going to talk to that endpoint. And let's say in this case, that user in the top left contacted, your www.mywebsite.com and says, hey, you came from North America, go to this endpoint. So now you're talking to a North American server. Well, if that server were to fail, it would then fail back to the client. The client wouldn't go to the customer. It would actually say, hey, I'm not communicating. It would make a call back to Traffic Manager and going, yep, that service is down. Now I want you to go to maybe the European server if that's the next best one for you. So Traffic Manager is not session-based. There's lots of reasons to consider to use Traffic Manager. It's inexpensive, so take a look at those pros and cons. But Traffic Manager is one way to shape global traffic, and it has 6 methods in which you can use to define that traffic. One of the other things I do want to call out about Traffic Manager, it does allow you to have a hierarchical structure. So for example, we may take North America traffic to North America, but once you're in North America, do I send you to a Spanish site? Do I send you to a Portuguese site? Do I send you to an English site or a French site for the Canadians? Or for some of the Canadians. So you can then have multiple traffic managers that send you to a North American traffic manager that then says, I'm now going to route you maybe based around language or geographic locations. The service has been around for a little bit, but it's newer than Traffic Manager. Azure Front Door Service becomes an inline service. So what you're going to do is now go to that endpoint and it's going to shape the traffic through it. So it's very similar what we talked about a few minutes ago about the app gateway. It's going to provide a lot of that app gateway features, but now at a global level. So Front Door Service is a global routing capability that also, that last bullet point, that provides a CDN or the Content Delivery Network. So in the last slide in this series, you're going to see that I'm going to talk about what a CDN is. This might be a replacement that if you want to get away from Traffic Manager and CDNs, you could use the Front Door Service now as a utility to provide all of that in one potential place. So Front Door Service, a great capability on a global level for traffic routing. So here's that CDN that I talked about. This is a great way to make large volumes of content available that are relatively static. So if you take a look at any of these streaming services that have movies, they don't have just one copy of that movie and everybody's watching that one copy. They take that one copy and they make multiple copies around the world that they make that information available to you. You take a look at some of these websites. Maybe you've got pictures of your products and you've got product details and imagery and maybe some videos that show how to use that product. I can take a single source of truth of that. You're seeing that on the far right-hand side of the slide. I can take a single source of that original content that I don't want everybody coming to that one content. I make this stuff available globally. And imagine what it would mean if that was here in North America, what it would mean to my Asia or my European users to have to come back to that one copy of that information. Now, again, as I said, if this is highly changeable, volatile data, you might want that single source of truth. But if it's static information, static web pages, it could be imagery that's on the web page that doesn't change that much. I want to take that content, and I have rules that say I want to pre-populate these endpoints, or called POPs, points of presence. And I can say on a regular schedule, send this information out. And so now what happens is your application will see that that information has been identified at a POP, and it will then route that traffic to the POP as opposed to going to the source of truth. The other thing you can do, there's whole things like TTLs, or time to live, because you're going to be paying for the storage in these other locations. So do I pre-populate the information? Great, it's there, it's faster, but now you're paying for the extra storage. And if it never gets used, you can time that out. You can flush them. You can repopulate them. There's all sorts of ways to automate the management of the storage of that content out in the CDN. But part of a solution, a way to make content available on a global basis. Today, we're going to be talking about Azure architecture, and specifically looking at designing for application protection services. Let's get into this. In a previous module, we talked about network connectivity, and we talked specifically about a thing called a VNet, or virtual network, and how if you had things called VNet peers, the internal communication of Azure goes from one Azure resource to another Azure resource using the Azure backbone. It's secure, but not encrypted traffic. We've added other features that, VPNs that allowed for some of those encrypted traffic. We then talked about how do we have public access granted to this, so whether it's through VPN gateways or ExpressRoute. Service endpoints, and in a few minutes, a private endpoint and private link services are a great service to provide secure access in a limited way to a service inside of Azure, either from Azure to Azure or from some other service to Azure itself. The first of these is called a service endpoint. And I'll do demonstrations of this at the end of the lecture portion, and you'll see how this works. But what we have is, at a global level, in another module, we talked about Azure Storage. And so you have the Azure Storage service in which you may have a storage account. Within that storage account, you have access to maybe an image that's in that storage account. Now, by default, that image might be available through what's called an HTTP connection. So if I were to draw this, if there was a picture that was in this storage account, and it was accessed over an HTTP or an HTTPS communication, I would go out through Azure to the public internet and then back into Azure to access that image. Probably not the most secure way or the most economical from a cost as well as performance method to be able to get this. I want to shape the traffic so it goes from some point in Azure directly to that service in Azure. And so you'll see this in the demonstration, and I'll do this on the whiteboards in the demonstration, but just I want to get through the topic here. What I'm going to now be able to do is a service endpoint says, don't go out to the internet to get access to the storage account. I want you to connect to the service storage in Azure and then go find the storage account. Now, a service endpoint connects you to a service. It could be a SQL service, and what you're going to connect to is all of SQL in Azure. Now, you don't have access to MySQL, and I don't have access to yours, but everything that you would have access to, you would have access to all of your SQL servers that you have access to because you're accessing the service SQL. You would have access to all the storage accounts because you're accessing the storage service. So a service endpoint is a great way to make a secure, protected connection within Azure to a service and not having to communicate with anything else. So service endpoints are a great way to broadly connect to a set of services. So if I had an application that might need to get information from multiple SQL servers or multiple storage accounts, I would create two service endpoints, one to the storage account service, one to the storage endpoint and one to the SQL endpoint. And I could gain access to multiple SQL servers and multiple storage accounts. The other example of that is to use what's called a private link and a private endpoint. This narrows the focus down, and what it does is it doesn't open up the VNet that you're communicating on to a service. It's going to put what is, all intents and purposes, a virtual network card in your network. And it's going to give it an IP address, and it ties that virtual IP address to a specific instance of a service. So in the previous example, I had my application or my service that needed in one VNet access to all of storage. I want it to connect to a very specific storage account. And so what it will do is it takes that IP address that I would then be able to call from my VNet. It goes to that IP address on my local VNet, and that private link service then links me to the direct storage account that I'm working with. Now I'm going to layer on top of this. Maybe I need a secure connection to get access to that storage account. Then I can have that service endpoint the private endpoint be able to go to Key Vault to get the necessary secure information to be able to check out and look at that image you're dealing with. So this is a great way to be able to architect solutions where in the past you might have been saying, I don't want to be able to have to create VPN connections and do all this. This really simplifies and highly secures the network communications from within inside of Azure. In addition to these methods, at the VNet level, which we've discovered or talked about in another lesson, there's a thing called an NSG, or Network Security Group. This is part of that defense in depth model that we've talked about. You want to have all sorts of blocks along the way. In a previous networking module, we talked about creating firewalls possibly. Within every VNet, we then get subnets that have NSGs, or network security groups. For all intents and purposes, think of it like a little firewall. And there's inbound rules and outbound rules that you can create at the subnet level. Going back, if you were to think about, if you took the networking unit, so I had a VNet that had subnets. I could actually block, as opposed to using user-defined routes, I could block the traffic from one subnet to another subnet within the same VNet. So I could do that with NSGs. The NSGs apply at two different levels. There's at the subnet level. There's also an NSG that applies at the network card level. So I could actually even restrict access to specific resources, VMs. If I got 2 or 3 in a subnet, I could restrict it at the subnet level as well as at the VNet or at the subnet level, as well as at the NIC level of the network device that you're trying to communicate with. So all these different ways to be able to provide that defense in depth, or a layered approach to be able to control your access. Taking that up a level, Azure firewalls, as well as third-party firewall tools that are available in the marketplace, are the traditional firewalls. And we typically put these things, there's some costs that go along with this. NSGs are free. And we strongly suggest that you use NSGs wherever possible, because they're free and they're a great way to secure that internal communication traffic that you're dealing with. Firewalls have a cost to go along with them, but they provide a higher level of service. The NSG is just a blocking service. It takes a look at source IP addresses or maybe source ports. So it only does a small check on the type of traffic that's coming in. Azure firewalls, as traditional firewalls do, they do deep packet inspection, SSL offloading. There's all these other capabilities that a firewall can provide. And our recommendation is to put firewalls, whether it be an Azure firewall or third party, in that public-private ingress-egress point. That's the great place to put these. And then internal, so I would have some public access point through the firewall, and on the far left-hand side of that image, you're seeing 2 subnets. I might have NSGs, which are free, at those subnet or the VNet levels that you're dealing with, at the subnets within the VNet levels that you're seeing within the Azure itself. So Azure firewalls. In a previous unit, we talked about the application gateway as a global routing service to route traffic that is regionally based. The app gateway provides that regionally based routing capabilities, but we talked about a thing called a WAF, or web application firewall. So we now have that capability to do that deep packet inspection. We can do the SSL offloading. We can do traffic routing based around the URLs that you're working with. So a great way to be able to provide some of that security using an application gateway firewall. By default, all the services into Azure, we've got 1,500 plus engineers that are monitoring the perimeter of Azure on a regular basis. And we provide a distributed denial of service protection across the Azure surface plane. We also do what is called noisy neighbor protection, so that if you're a small local user of a resource within Azure, and you're so happen to be deployed into the same region or data center that maybe some global behemoth is also using, you don't want their traffic to potentially impact your ability to do your work. That's where the SLAs that we've talked about throughout this series are important to you, because we have an SLA that we guarantee that you're going to get a specific level of service regardless of what's going on in other users of Azure itself. So the DDoS protection is generally available for everybody. It's there for free, but you can elevate that permission. And so now what you're going to be able to do is to get an extra layer of protection. And this is a great way to be able to make sure that, we're doing some of that monitoring ourselves. I always use the example of, we used to call it knocking 9 doors. Someone knocking at your door and you answer the door and there's no one there. That might not be an alert for you. Well, that's weird. Someone knocked at my door. But if you have neighborhood watch and we saw that, everybody had their door knocked on, that might be an indication of a problem. So that's one of the benefits of having Microsoft monitor the entire plane of Azure, because we get to see the neighborhood. We get to see the activity that might say, hey, wow, we see a bad actor coming from a geographic location, and it's trying these attacks across a whole variety. While we're stopping them at each one of them, we want to be able to stop it at the source and stop it from knocking on everybody's door. So DDoS protection, a feature that's available to you. There's a basic version for free, but you may want to elevate to the paid version. Azure Bastion is another service that you may want to consider. People would often create a term called a jump box, maybe, or a PAW, privileged access workstation, that you would then connect to be able to gain access to a set of resources. Azure Bastion as a service is a capability that we provision and lock down and secure a resource for all intents and purposes. It's a device, a jump box that you would be able to connect to that then gives you connectivity to backend services. It has multiple people that can connect to this. It is patched. It's maintained on a regular basis. But Azure Bastion would be our recommended way to create RDP connectivity, because you make a connection to Azure Bastion, and you can do this over even an HTTPS connection. You connect to Azure Bastion and then use the RDP service to connect to those backend services. Strongly recommend that you do this. You can deploy Azure Bastion to a hub subnet in a hub VNet that you're dealing with, and it would give you access to all of the back-end spoke networks that it's connected to. I've had some customers that weren't aware of the actual design, and they were deploying Azure Bastion in every single VNet. You don't have to do that. You can create a hub and spoke environment. We've talked about that in other segments of this series, where you can actually create it at some hub network and then be able to gain access to all the spokes through that Bastion network. In addition to those services, just in time, or JIT, is the ability, using those firewall rules, to be able to open up ports for limited periods of time. You want to have this layered approach for security. I've mentioned in previous lessons that I'll often meet people at beaches or on vacation and going, hey, are you an administrator for your company? Do you have that capability to do it right now? And they go, yeah. I'm going, but you're on vacation. Just in time, as an example, says you only have the capability to do something at the time you need to do this. And you can either request it or elevate to that level. So you have the capability to control just-in-time activity. For example, Bob works 9 to 5, Monday to Friday. Well, he doesn't need that activity possibly on the weekend. So I can restrict a specific activity through the just-in-time network access services to say that someone is not going to be able to do this. And so using the NSGs to set that feature up is a way to actually secure this so that people are not doing things out of bound, or if they're trying to, they have to go through an approval process to be able to do it. So we saw that at the start of the module, we covered a lot of those traditional networking pieces. You saw just right near the end, we got more into some of those very advanced Azure services one you see on the screen right now, the just-in-time capabilities, the app gateways, and some of those other components. Know that, last time I checked, there was a little over 10,000 items in our marketplace. A lot of them are from third parties. So, if you wanted Cisco components, or if you had other companies like F5, Fortinet, they've got all of those different offerings that are available. So if you needed that consistency between your on-premises world and Azure, they're there. We're not going to cover those. I'm going to focus on the Microsoft services, and I want to focus around a couple of them specifically. And I love those last capabilities of service endpoints that you have, and private endpoints. Those are, I think, very critical pieces to add to a network infrastructure inside of Azure to really provide a layer of security that you didn't have. And they're relatively new, within the last couple of years into Azure. So if your people have been working in Azure for a while and not familiar with that, it's strongly recommend that it's something you add to your solution. So that's where I'm going to focus a lot of my demonstration time on, is some of those newer services so that you can get a feel for what they are. So let's get into that demo. Taking a look at the networking features, you can see that I've got a number of VNets that have been configured. I'm going to take a look at these top group, and I've got a series of 000, 001, 002, all the way down to 012, just a numbering system, whether it be in Europe, whether it be in the United States. And so I've got in the region based, because remember, VNets are a regionally based unit of networking, and I've got a number of VNets that are in West US2, Central US, East US, East US2, and I've got some in Europe. Now you're going to see, I'm going to go into the hub network. We talked about having a hub and spoke in the class as one of the options. And so I'm going to come into this hub network and take a look at some of its configuration. Under the settings, I can take a look at the address space that was allocated to this VNet, and it's a 10.255.0.0/24, giving me 256 IP addresses across the entire range. You can see that I've got a number of peered virtual networks with this, and I'm going to come back down here later on, down on the left-hand side, and show the specific peers for this address space. We can take a look at the connected devices inside of this VNet, and I've got a Bastion network, and I've got a number of network cards to a privileged access workstation, as well as a series of network cards that are assigned to virtual machine. I can then take a look at the subnets that were configured on this VNet, and remember, you can have as many subnets as you need that you use to divide up the address space for the VNet itself. And you can see I've used a variety of CIDR notations of /26, 28 that gives me different address ranges of a custom subnet. I've created an Azure Bastion subnet, a gateway subnet, an Azure Firewall subnet. These names are very specific for the types of resources we're deployed to it. And I've got a resource subnet that I've got for resources like domain controllers that I put into that subnet. For the Bastion network, you can see that I had a Bastion network. I've deployed an Azure Bastion service that now allows me to, over an HTTPS connection, to be able to connect to that VNet and be able to access all of its peered resources. We're using an RDP connection. I've got a number of domain controllers that I simulated a global Active Directory domain services for that networking environment. Taking a look at my peerings, you can see that I've got a peering name. So I went from my 000 VNet to 002, and it's peered with US Central. I've got from 000 to 003, and that's going to go to US East. I've got 003, the name of this VNet, and it's going to 004, and that's going to my East US2. I go from 000 to 010, and that's going to go to my UK. So I've got a set of peers that I've set up. And if I go to one of these other peers, you'll see that it has a peer back to this one. So let me go to one of these subnets. I'm just going to click on it. And you can now see that I'm at the 012 virtual network. And if I look at its peers, you'll see that it comes back to 000. Now we take a look at the terms a service endpoint and a private endpoint. Remember, we talked about, instead of having a virtual machine or some resource that was on this VNet in one of its subnets, connecting to a storage account out through the public internet, it would make sense to be able to access it locally over the Azure backbone. So looking at the service endpoints, I could add one if I wanted. And remember, a a service endpoint opens up access to the entire Azure service, those resource providers that I talked about. And so I can open it up to all of Microsoft SQL, regardless of which region it's deployed in. If it's a Microsoft SQL resource deployed someplace in Azure, this VNet would be able to have access to the SQL service. And you can see a wide range of the Azure services. Now that's going to be considerably different than if I go to the private endpoint. Remember, a private endpoint was a one-to-one relationship. And now what it's going to do is it would have a private endpoint to a specific instance of a resource. And I'll go to a resource and show you how I can create that private endpoint. So I've switched to an Azure storage account. You'll see that this storage account has been deployed into East US. And what I can now do is under networking, I could create firewalls and virtual networks, or I can create a private endpoint connection to this storage account. So that's what I'm going to do. I'm going to create a private endpoint. I'm going to call it AZ305 demo. It's going to have a network card of that name. And where do I want to deploy this network card? I want to place this network card in West US 2, which was the region my 000 VNet was created in. We saw that we had a variety of services available in this storage account, and whether it be blob storage, table storage, queue storage, I'll take blob storage that I want to make available to that network. Which virtual network do I want to make it available to? And we saw we had the 00 hub VNet, and I can select specific subnets within that VNet. I'm going to assign it to the resources subnet. Do I want to give it a private IP address, dynamically allocate an IP address, or do I want to statically map it? There is automatic DHCP set up in that subnet, so I'll leave it at there. I'm not going to create DNS, and I'll create this. So that took a few minutes to deploy, but you can see it deployed a number of things to support that private endpoint in US West 2. So I'm going to go to the resource, and you'll see that it has an IP address that is based around the VNet in West US 2. Now, if I go to that subnet that we deployed it in, if remember it was the resource subnet in the 000 VNet, go back to my virtual network and take a look at my subnet. I should have pointed out before, but this was at 56 before. It's taken up one of the IP addresses, and we'll take a look at what's in that address range. We'll take a look at the resources that are now allocated. So looking at the connected devices, I don't know if you remember, but if you rewind the video, you saw we had a Bastion network, we had the two domain controllers and the PA. Now we have the AZ305 demo NIC, which is the network address that I could now send local resources to at 10.255.0.199, and that would connect me to the US East implementation of that storage account. I wouldn't use the storage account information. I would use this network address. Let's return to the lesson. Welcome back from the demo. There is a whole class that we have on networking. AZ700, you see it listed there, that gets into deep dive into a lot of the concepts and more that we had in this lesson. Remember, this is an architect's class. Your job is not to actually configure these pieces. Your job is to figure out what part they play in an architected solution. And wherever possible, I would suggest, if you're architecting a solution, try not to leverage those old technologies, but the newer forms. Look at service endpoints. Look at private endpoints as ways to do these things, as opposed to traditional networking with, gateway subnets and firewalls. They're going to be way more efficient. They're going to be way more secure for you to be able to get and work with these. But, you've got every single tool in your tool belt that you've had before from a networking perspective, as well as a whole new component of Azure services. From a design perspective, you may want to ask those questions of what they need, where they need it, and is there something specific about the older technology, or can they use something like a service endpoint? That'd be one of the first questions I would ever ask in an architecting workshop is, why can't we use either a service endpoint or a private endpoint or a managed identity, and then talk off of that point as opposed to just going back to what you've known before. So take a look at these, put them into your solution. They're a great way to secure and optimize your application performance in Azure. So thanks very much for listening, and I look forward to seeing you at a future lesson.